Yes, so thank you everyone for joining us for this session. This is meant to be an educational session on security best practices for anyone who is developing a MetaMask Snap. And so in this session, what we're going to cover is we'll give a quick intro on what is a snap. I think everyone here is already very familiar with that, but just in case, we'll just cover the basics again. And then we'll give an overview of snap security, why it's important, and some of the key things to think about. We're going to have a panel Q&A. So I have some guests here who are going to be helping us better understand snap security. And then we'll have an opportunity for anyone to ask questions. So feel free to jump in and participate during that time. If you have some burning question, now is a great time to ask. So let me do some quick introductions. So our moderator will be Valentine from Diligence. And then our panelists, we have John Stevens from Veradice and Nir Duan from Safer, who are going to be speaking with us today. They're both, actually all three in this case are auditors, security auditors who are very familiar with auditing JavaScript code and have already had some experience in knowing what to look out for in terms of when reviewing snaps. And we'll be sharing some of their learnings today. And for those of you that don't know, my name is Christian Montoya, and I'm the product manager for MetaMask Snaps.
Yeah, thank you, Christian, for the introduction. Maybe John and Nir, you can quickly introduce yourself right now. Maybe John, you can start.
Yeah, sure. So hi, I'm John. I'm the CTO of Veradice. So we are a security company that focuses a lot on tools, particularly in building tools to help secure all parts of the blockchain ecosystem, including ZK circuits, smart contracts, and in this case, we're talking about wallet extensions. And so that's something that we've been working on a lot lately. And so, yeah, happy to be here and talk more about snaps.
Thank you, John. Nir, so if you want to introduce yourself quickly.
Yeah. Hey guys, my name is Nir. I'm the CEO and co-founder of Safer. I'm, as mentioned, a security auditor, security researcher myself. I used to work for the Israeli government and find security vulnerabilities before I founded Safer. Passionate about Web3 security. Safer is trying to provide a very holistic approach to auditing and cover 100% of all attack surfaces. Something I will touch in more depth later this conversation. Looking forward to educate you guys as much as I can.
Amazing. Thank you, Nir. And yeah, I'll finish by quickly introducing myself. So I'm Valentin, and I'm working as a security engineer at Diligence, basically, so consensus security team. We also both build products and deliver auditing services for different kind of Web3 technologies. And yeah, today I'm happy to be here to talk about Snap security and moderate this panel with our great speakers. Thank you. So I'll let you, Christian, maybe continue and tell us more about what are snaps.
Yes, thank you. So if you go to the next slide, so snaps are like mods for MetaMask. That's one way that we like to describe them, so you can use mods in like Minecraft or something like that. And this is really key to understanding that these run inside of MetaMask and in some cases modify the MetaMask experience and interact with the APIs inside of MetaMask. And the way that this operates is that we have this execution environment running inside of MetaMask. And in that execution environment, we have something called secure ECMAScript or hardened JavaScript, which limits the capabilities of what a snap can do and ensures that these snaps are sandboxed inside of that environment. And so everything revolves around this permissions model where snaps request specific permissions and then that gives them capabilities. And some of those capabilities are very powerful. Includes things like accessing the network, saving to the user's disk, deriving keys for various derivation paths, storing data. And so these are things that, once the snap has these capabilities, those are very powerful. And then, whoever is writing the snap should be very cautious about what they do with those capabilities. And then those snaps can have their own APIs. Like I said, they can use the methods in MetaMask, and there's even some methods that are exclusive to snaps. And so the way that this works, if you go to the next slide, is A snap is an NPM package. If you're familiar with doing NPM, no, go back one. If you're familiar with doing node development, you have source code, JavaScript, TypeScript. You can even use WASM. There's a manifest file that includes like what permissions it's going to request and some information about the snap. And then there's a package.json, which is standard for uploading to NPM and creating an NPM package. We provide the tools to bundle all of that and publish it to NPM and make it available from a dApp. And so the way these are distributed, it's you publish a snap to NPM, you deploy a dApp to invite users to install your snap. And when users go to that dApp, and they click to connect to the snap, MetaMask will prompt users to install the snap, right? So they'll be presented with a prompt that says, this snap is requesting these permissions. Do you want to install it? And once the snap is installed, then it's able to run and do things with those permissions and interact with MetaMask and augment the wallet experience in various ways. And so when you've installed snaps, you see a menu under settings with the snaps that you've installed. So in this case, you see the Filecoin snap and the Starknet snap. And then other dApps can interact with your snap too. So some snaps are designed to interact with dApps and to present that API to various dApps. And so there's other considerations about how to manage connections from different dApps within a snap and other things that you have to look out for when you're building a snap that does this. But this is part of what how MetaMask works. MetaMask connects to various dApps, and snaps can do that too. So that's the end of my introduction, Valentin. So over to you. Thank you.
Thank you very much, Christian, for the great introduction. So yeah, I'll continue by quickly talking about Snap security and why it's important, basically. So as you mentioned, Christian, Snaps actually run into in MetaMask, right? They're a part of MetaMask, even if they're in a secured environment, like compartmented. Still, they can be granted like really high privileges. So for instance, like just accessing your key material, right? Yeah, you have to, like, developers have to be really careful about like what they're doing and the privileges that they're using. And so also because users generally trust MetaMask, right? It's their wallet. They will happily trust snaps too, basically. So it's really important to understand that because like to implement good security practices, generally developers have to also understand the end user point of view, basically. So yeah, this leads me to talking a bit about what's Snap security. Well, I think a good way to view that is that so users should be able to trust snaps roughly in the same way, or even like exactly in the same way that they trust MetaMask. And so snaps should be viewed basically as a MetaMask trusted module. And I think it's really useful for developers to see snaps that way. And yeah, because something MetaMask would not do, basically snaps most likely shouldn't do it either. So yeah, that's a good way to think about things. So now maybe to dive a bit more into the details, I'd like to turn to John and Nir. We'll try to make this session a bit interactive. So I'll ask you guys a bunch of broad questions, but yeah, feel free to interrupt and add details if you feel like it. So maybe we can start with you, Nir, basically. So, when we talk about security, there is generally this question of responsibility, basically. So who is responsible for what? Like, is it the developer? Is it the end user? So yeah, if you could like give us your opinion on that. So what are basically developers' responsibilities when we're talking about Snap security?
Yeah, so I think in terms of responsibility, I want to believe that we all share the responsibility equally. And by way, I mean, me as an auditor, you as MetaMask, and the developers as the developers. We as an auditor need to do a great job in making sure we are not missing any security vulnerability. But even if we do the best job possible, there is still responsibility on the developers, because at the end, especially the builders and the guy who built the protocol. There is so many attack vectors that cannot be controlled under the audit scope, no matter how hard we want to do it to control them. Either the employees behind the MetaMask Snap, either servers and stuff that can always be changing. So we need to make sure from the developer side, developers need to make sure they always look at security seriously, especially as you mentioned now, when users download snaps, they're gonna think, oh great, it's MetaMask. They don't know front-end, back-end extension and how the code runs, and they shouldn't. They know it's MetaMask and it's secure. So developers need to be extremely cautious and extremely alerted about the security of the snaps they're building. It's true to say it on everything you build on Web3, but I think on Snaps even more. You're gonna get US developers gonna get more traction, more users, but there is a responsibility that come with this opportunity.
Thank you very much, Nir.
Yeah.
John, yeah, maybe you want to add the point.
Yeah, so just to chime in here a little bit, developers certainly are the ones who are responsible for developing the Snap, but it's also their responsibility or your responsibility to place some of the decision-making ability on the user itself. So with a MetaMask Snap, you're able to get access to a lot of data and you're able to perform actions on behalf of the user. And you need to make sure that users are capable of reasoning about what it is the Snap is actually doing on their behalf, because really you're representing them. And so one thing that we'll talk about, I'm sure a lot during this panel, is about informing users properly of what it is that you're doing. That way, when it comes to a mistake, let's say if a user does something improperly, like send their key to someone, they had knowledge of it and they knew what was going on. Because if they don't, then that is where a problem is on the developer side rather than the end user side.
Absolutely.
So,
yeah.
informed consent.
Yeah, absolutely. You're absolutely right. Thank you, guys. Maybe John, you can continue on the second one. So basically, I think it's very useful generally for developers. I mean, security conscious developers to think about and know what our auditors are specifically looking at when they're actually writing the code. So maybe you can give us some insights, on what you guys and your team are, what kind of bugs basically you're trying to look at when auditing Snaps.
Right. So this isn't going to be an exhaustive list, but I'll name a couple of things that we found and a couple of things that we look for. So probably the biggest issue that auditors are looking for when they look at these snaps is they're looking for privacy leakages. So what I mean by that is you have access to a lot of private data, like private keys, and you want to make sure that that data is being kept safe and isn't leaked in an improper way. And so an example of this would be something like printing a key out to console or something like that. You just want to make sure that whatever you're doing is preserving the user's privacy and doesn't have the possibility of being leaked to an unsafe source. Other things that we commonly look for are things like user prompts. And so I brought up user consent earlier. So before doing really anything, the user should be made aware of what is being done. So for example, if you plan on sending a transaction, the user should know the information about the transaction being sent and should be capable of saying, yes, this is something that I want the Snap to do on my behalf. So user prompts is another thing that's very important. Like if you're planning on scheduling transactions to occur every so often, for example, you can still prompt the user, just do it when the user consents to wanting a transaction to be sent every so often. Another thing is things like granting too many permissions to your Snap. So like was mentioned earlier, Snaps have this permission-based model, and you should only be granting permissions that your Snap actually plans on using. And a little bit later, maybe when we talk about some of the Snaps that we've seen, I can give a couple of examples of why this is actually really important. Other things that are important are, honestly, things like Web 2 bugs or just generic TypeScript bugs. And so what I mean by that is with Web 2 bugs, you can have things like query injection and stuff like that, where you might be building a URL in order to send a request to this external service. But if you're not constructing that URL in a proper way, then it's possible that someone could inject some queries and perform something that you don't want to, that you don't intend them to on your behalf. And so in that case, you want to make sure that people are actually using your APIs safely. And so using all, let's say, knowledge from both Web 2 and, in this case, MetaMask is very important. And then finally, some other things are like, if you are allowing people to connect to your Snap, and if you have a specific, let's say, if you only want a specific site to connect to your Snap, that's something that you can enforce in code. And so enforcing through a whitelist that only certain people can connect to your Snap can also be powerful, because one thing that we expect to see is most likely there are going to be phishing attacks or something like that, where people will try to gain access to your Snap through this untrusted site. And so just minimizing the attack surface in that way is also very useful, because, people are going to try to get access to really any sort of RPC API that you exposed in order to try to get user information or to send improper transactions. So yeah, that's very important. And then finally, the last thing that I'll mention is just logic errors. One thing that we find a lot in not only Snaps, but in other ecosystems that we look at as well, is just people making mistakes, them intending to do one thing and actually doing another thing. And so understanding the logic of the Snap and trying to make sure that people are actually coding the Snap in a way that's consistent with what they intend is also something that we normally look for as security auditors.
Thank you very much, for this already kind of extensive list. So yeah, it's I think like most of the issues that you mentioned are also things we noticed in our audits. So I've definitely seen some kind of common patterns there. And especially, I think you, and I want to emphasize the point that you made of really prompting the users, for every action, because I think this is something that a lot of developers forget, and it's extremely, extremely important. Never assume that the user has been informed enough, basically. So always make sure that he's aware of every action. Nir, do you want to add something there, or?
I think you guys covered more than everything.
Okay, great. But maybe though you can, if we talk a bit more generally, broadly speaking, you can tell us a bit about the overall attack surface and maybe the mitigations, of attacks in general.
Yeah, I think I'll start by first talking about the attack surface, and mitigation are a little bit harder because it's more implementation related, but I'll try. So the way I see it, there is several components or several features where you need to look at and take care of when you're building a Snap. I would say the riskiest one, which is probably obvious to everyone here, is private keys. If you are a Snap, mainly all the non-EVM snaps that you need to handle in some way private keys, you need to make sure there is the least amount of any API, any calls that call to this private keys. You don't want to log in any way anything that's related to private keys, even in crashes and stuff. You don't want the least possible function calling the function of the retrieving the private keys, and you want to make sure you just touch them the least possible way. And of course, you never send them to a server. If you have to send them to a remote server because of your functionality, one, you probably doing something wrong, and two, if you still need to do it, there is like, talk to an expert. Don't do it alone and think you're doing stuff correctly. I can't help you right now just from saying how to do it correctly. So yeah, private keys, as always, the most scariest place, and make sure handle responsibly as possible. The second attack vector, everything is user input. Keep in mind that everything the user is giving you as an input is malicious, because it will be when bad actors will try. So, and we see it over tons of snaps we did. It's always about user input validation. These attacks are much more common than stealing private keys in any ways, because are much easier. They have a little bit less significance than stealing private keys, but still extremely important. Most of the vulnerabilities that gonna be in your snap are gonna be in some way or probably related to the user input. So every user input you guys have over your snaps, make sure you sanitize it and you validate it, and try to think of the most creative way of data user can input to these fields and how you mitigate from them. It's hard to give like specific solutions for problem I don't know yet, because it's based on your implementation, but it is a place you should look at. Another important area that I think is really important is phishing attacks. I'm not sure if everyone here, but if you don't familiar, I highly suggest to read a little bit about the Badger DAO hack that happened a few years ago. $130 million got stolen only on bad UI inside the wallet that people misunderstood on how you approve a DApp to transfer your coins. So, and we talked about here a lot, when people gonna see transactions over MetaMask, they don't know if it's a snap or it's MetaMask, and they don't care, they trust it. So you need to make sure that if you do have any UI capabilities, or you of course have UI in your snap, but you need to make sure that any modular UI or dynamically created UI is extremely safeguarded, and there is no way for attackers to modify your UI, because they will do it in a way that will make malicious transaction look non-malicious, and users will sign them. So this is also a very important area. Additional stuff I want to talk about on attack surface on the snaps is stuff that are out of scope from the snaps, and I think it's also extremely relevant. A lot of snaps communicating with server, providing information, retrieving information. These servers are also a great attack vectors for malicious actors. You need to make sure these servers, if they for some reason handle keys, this server has been audited. You need to make sure they can't leak important information on your user, handle the transaction in some way. So these servers are also a huge attack vector that need to be looked at. The way I see it, these are the main attack vectors, and I know I didn't give you like specific things to do, because I think you should look at it as guidelines. Like, when you get user input, you need to stop for a second and think about it. When you handle private keys, you need to stop and think, do I do the bare minimum of operations with these private keys, or do I do stuff that are not required? So this is the way I see it. I love to hear, guys, John, Valentin, if you have anything to add.
No, I think this is great. And really, I think that the only thing that I would add to this is, again, just making sure users know what's going on, because if even if you're informing someone, if you aren't, let's say your user message is just something like, I want to send a transaction or something like that, but you're not specifying the transaction, then that can make it really easy for some of the attacks that I talked about previously, as well as some of the things that Nir just talked about, can happen.
Yeah. Thank you very much, guys, for your great input. I completely agree. I'm gonna phrase it in a straightforward way, but basically you have to assume that your user is dumb and he's not aware of like the context whatsoever, you know, because yeah, that's the only way to really like think about everything, and especially when you're dealing with like privileged operations. Yeah, make sure that your user is super aware, even like several times of what you're doing, basically, what he is doing, basically. So yeah, thank you guys for all your inputs. Maybe we can finish this session basically by yeah, to make things a bit more concrete and illustrate like what we said for our listeners, basically. So if you guys could like just tell us a bit about one specific example that you and your team audited, you know. So even if like you anonymize the stuff, because like maybe you can talk about like don't cite names, you know, but yeah, like some specific examples that you guys audited, and yeah. So maybe I don't know, John, do you want to start?
Sure. So yeah, this is talking about a client whose report we haven't released yet. So I'm not going to say any names here, but I can talk a little bit about some of the things that we found. So this client was implementing a wallet for a non-EVM chain. And so basically what that means is one thing that they needed to do is they needed to interact a lot with private keys because they were doing things like sending transactions and stuff like that on behalf of the user. And so we actually found a couple of pretty important things here, but they all kind of boiled down to one thing. And this is why I keep bringing up user consent. Is so here, basically, I'm going to talk about kind of three factors that all combined in order to create some, you know, possibly pretty damaging behavior if you combine all three of them. So the first one is just going to talk about a little bit of information leakages. So this particular client had an API that would allow an RPC request to request a private key from the snap itself. And so that means that anyone who has, you know, the ability to interact with the snap could possibly export the private key. And then, you know, obviously at that point, they've got the user's private key, which can be pretty bad. And so that's kind of an example of user leakages. However, or of, sorry, information leakage. But, you know, if you're doing this to a trusted source, then, you know, maybe that's not so bad. And here's where the second thing comes in, which is not allowing the user to actually confirm that they want to perform this interaction. So basically, when this RPC request is made, there was no confirmation dialogue for the user to say, yes, I actually want this private key to be exported. So as a result, any site that had the ability to connect with this particular snap would have had the ability to get a user's private key. And because they didn't have any sort of whitelist in order to say, I only want to interact with this trusted site, that meant that it possibly could be leaked to some bad actors or unknown sources through something like a phishing attack. The other thing, though, and this is where the permissions comes in, is they granted too many permissions or permissions that weren't actually needed for the snap itself. And so specifically, they needed the RPC permission, obviously, to allow communication, but they granted RPC permissions to both snaps as well as other sites. And so the important thing here is they didn't actually need other snaps to communicate with their snap. There really was no reason for them to have that permission. And so as a result, other snaps also would be able to use this method, the, you know, private key or get private key RPC request in order to get this private key. And now you had to trust any other snap that was installed on that user's device. And, you know, one thing that we can probably expect at some point is someone trying to develop a malicious snap in order to get some of this information. And so for that reason, you have to be very careful about, you know, permissions, making sure users are aware of all of the important things that you're doing. And also, you have to be very careful about those private keys.
Great. Yeah, absolutely. Thank you for the great example. So you guys know what you must not do, basically, when dealing with privileged operations. Nir, maybe you can also like quickly tell us about something you saw.
Yeah, sure. So we actually have a really cool story about a vulnerability we found in a security snap. I don't want to butcher the story, so I brought a team member, or I think he's gonna do way better job about telling the story. He was the researcher who found this. I'm giving him all the credit.
Thank you. So guys, I want to tell you a little bit about the interesting story that we had with Snap. The Snap is kind of like an antivirus for Web3, should allow me about suspicious origins and suspicious transactions. And for those of you who can imagine that, this world of kind of like antiviruses is always cat and a mouse trying to figure out is it a legitimate resource or not, and at that point bad actors trying to discuss themselves and kind of hide the fact that they're doing something malicious, and it's a never-ending game. So the winning party will be the one that collects the right data and classify everything correctly. So the Snap was collecting data about the usages, and every time you interact with that, there was some metadata that's sent to a backend server. And when things get complex with not just a Snap anymore, it's also a backend server, it's becoming more complex and more vulnerability arises. And all the machine learning models on the backend, while collecting all the metadata, they did their magic and decided what is legitimate and what is not. And this metadata was just an API call from the Snap. What we figured out that we could call this API directly, meaning not even intercepting the Snap or intercepting those requests. We were able to send arbitrary data for this backend server and spamming it with whatever data that we wanted, and we could send a lot of kind of like legitimate data and whitelist, or making sure that the backend thinks that evil.com is actually the right website and it's a good website. But behind the scene, obviously, that's not the case. And we were able to basically bypass the mechanism of this security snap, which defeated the purpose. So I guess the takeaway from that story is Snap has its own sandbox and it's totally isolated. But once you put more complexity into the story, you have to look on other stuff as well. And this backend server obviously had a lot of other issues around authorization. And we figure out with the team and figure out what solutions should be implemented under a specific case. And yeah, that was how we bypass the antivirus mechanism, basically.
Thank you very much for that. Yeah, that's super interesting. I think that's something we haven't explicitly mentioned. I mean, maybe we mentioned quickly yet here, but like, yeah, because you have like different kinds of snap, of course, like some snaps basically rely on other components like backends, for instance. And of course, like these components are also really important to secure. And if you get those wrong, well, it of course will have an impact on the Snaps front end. So basically what's installed in the MetaMask wallet. So yeah, you also have to be careful about that. So yeah, thank you both. I think you guys already told us a lot and got most of the points. I'll quickly also mention an example that goes in line of what you guys said. So yeah, this was also like a snap basically that's that handle like user private keys basically. So it would allow users to do different kind of operations like signing, broadcasting transactions, or even messages on different chains. Yeah, we found a bunch of vulnerabilities in the Snap, but I won't extend on them because you guys already told us a lot about that. So not asking the user, for instance, to before signing a message, so that's critical, right? Any website could just like send an RPC request, and the Snap would happily like just sign a request without prompting the user. So of course, this is something you should never do. But yeah, maybe something else that's a bit more interesting. So this goes in line with what I mentioned in the introduction, basically, where I think it's interesting for developers to think about what a MetaMask would actually prompt the users to do before doing any kind of operation. So for this Snap, basically, it would allow the dApp to communicate with different chains, basically. But the thing is that like once you connected the Snap to the dApp, basically, you would by default grant the Snap the access to every chain. So it wouldn't like ask you to connect to Ethereum or like Binance chain or like Avalanche or whatever. It would like by default, you would connect to every chain. And this is of course like something that's like a bit dangerous, right? Because like generally you want permissions to be granular, and you would prefer, such as MetaMask, basically to just like connect one chain to the website instead of by default like having the dApp basically being able to invoke and send transactions for every chain basically. So yeah, I think this is something quite interesting, and you guys should always make sure to think about basically what MetaMask would do basically when doing an operation, and trying to be in line with that and not like bypass like default security measures. So yeah. So thank you guys for like your great input. I think it's been super helpful for our listeners. So maybe let's now ask our audience if they have questions for you. Yeah, so feel free guys to unmute yourselves or raise your hands and ask question. You can also write them in the chat if you don't want to speak or you can't. Well, it seems we've been super clear. Let's maybe, oh, there is one. So Piotr asks, what are some of the existing tools from TypeScript, JavaScript security realm that we can use today to improve the security of our snaps? So
yeah, that's a good question. There are several linters and static analyzers that you can use in order to check and make sure you're actually using TypeScript or JavaScript correctly. Another thing that's pretty useful that not very many people do is when using TypeScript, doing or enforcing types strictly rather than doing this kind of fuzzy type checking that TypeScript allows you to do can also be very useful, because it will force you to handle edge cases that you might not have thought of. And so, yeah, I mean, really, what I would do is focus on, or if I was going to be developing Snap, I would turn on the strict typing capability in TypeScript. I would also use some linters and static analyzers that are available. I mean, there's a lot of them out there, particularly for linters that will check things like coding style and stuff like that.
absolutely, yeah. Thank you.
I think it's not a tool that directly help the security, but it's a tool that everyone know they should do to help the security. write tests. Write as much tests as possible, make the code clear, make sure, and I'm talking unit tests, make sure you're not forgetting some like all the unrelated deprecated should not be functions, and this is really helps the security, and it really helps our audits as well.
Yeah, absolutely. Thank you, Nir, for saying this. Actually, I think this is also something we often see, but it's not like it's often the case in a bunch of different software. Like unit tests are often like not good enough or like inexistent sometimes, and I think it's, even though like some components can be quite challenging to test, it's extremely important, and I think it can like massively improve the robustness and like the security of the product, basically.
Yeah, I would add a minor thing regarding testing as well. It can be very tempting to ChatGPT all your tests, but it wouldn't be the same, especially if it's not for. But this should be responsible and good quality tests.
Yeah, thank you for mentioning that. Absolutely. We have another question from Emil. So, is passing secure ECMAScript evaluate critical parts of an audit? We have issues where it throws when analyzing WebAssembly that instantiates. Yeah, do you guys want to take that up?
No, that's not a critical part of an audit. I mean, basically, what an audit will do, or at least what an audit will do at Verdice, is we will use tools like this in order to try to help us find issues in addition to performing manual auditing. However, we are aware that these tools can have false positives. So in this case, like there are cases where a tool will report something like, I think there's an issue here. You specifically mentioned WebAssembly.instantiate. And so in that case, those are issues that an auditor would have to look at and have to convince themselves that no, the tool is wrong and that you are right. And so it's not critical to, pass that. Instead, you have to be capable of communicating, or probably having a comment that says something along the lines of, it doesn't pass for this reason, is what I would say would be the most helpful there.
Amazing, great. Thank you for the great answer. So maybe the next one. So Eduardo asks us, like, what would you say is the best way to uniquely and securely identify which DApp or snap is trying to invoke our snap, basically? So which DApp is trying to invoke our snap? Do you guys want to?
Yeah, there is some whitelisting functionality that you can have in a snap. And so you can whitelist particular dApps or websites. I know I'm not quite certain about how to uniquely identify snaps off the top of my head. But if you do know like what specific dApp or what specific snap should be interacting with yours, that's something that you should communicate to your auditors by saying, like, we expect this will only be interacted with by X or Y, and they should look into it and make sure that those are the only ones that can interact with it. And so I know how to do that for dApps. I don't remember off the top of my head how to do that for snaps. Maybe someone else does.
Just chiming in, you want to rely on the browser mechanism, and that's where we're talking either course or basically the origin. So if you can, I'm not sure what's your specific use case, but the origin is the most trusted input that you have. And you can't assume that everything that happens in, I don't know, in the transaction data or whatsoever is not tampered by the end user. So again, not sure what your use case, but origin is usually is the solution for those kind of things, if it's possible.
Yeah, so the next question asks specifically about like EIPs. And so if you're trying to make sure that you're only being interacted with by a snap that implements a particular EIP, that's going to be hard from a snap because someone can always misrepresent that they are actually implementing that EIP, or they can add in additional functionality. So trying to make sure a particular dApp that implements an EIP is going to be difficult to verify on the side of the snap. Yeah, essentially, yeah, that would be difficult to do on the side of the snap. There might be some ways that you can do it, but that could require like sending some dummy messages or something like that and validating that you get something consistent back. But
yeah, I think it's going to be hard. I agree with you to implement something that is very robust in that case. What I would try to do is make sure that like other dApps or snaps basically can't mess with your own snap. So yeah, that way, like having like safe defaults. I guess it's heavily dependent on the use case, but yeah. Any other questions? Well, it seems that, oh, the last one. So Jake, you mentioned phishing attacks earlier, which implies doubling down or authentication should be top priority. Which authentication mechanism past sign-in with Ethereum have you seen recommend?
right. So we had one particular client who wanted to implement some sort of password mechanism. So this would be sign-in. And they were saying that they were having difficulty actually providing that functionality within their snap. So some of these mechanisms you're going to have difficulty implementing within a snap because of the restricted execution environment. When you're talking about authentication mechanisms, are we talking about for external sites or for users to validate that they are, they actually want to perform some privileged action?
And maybe while we're waiting for the response, if we're talking authentication, kind of like Web 2 authentication, we had a client who wanted social login, and in the end of the day, they really wanted to interact with the JWT within the snap or having some kind of API token within the snap. That wasn't easy to implement. There was a lot of hacks. I didn't like the end solution. Still working with them to figure out if we can do something more streamlined. But that's a big problem to solve.
Yeah, I mean, like I said, in our case, it was someone trying to specifically have their own method of validating passwords, and then I guess likely communicating with the server in order to validate that password. And they weren't able to get something like that to work easily in their snap. So if it's validating that the correct user is interacting with the device, so for example, if you want to protect someone from gaining physical access to the device and then doing something potentially malicious, in most cases, you have to rely on MetaMask to provide the security. So for example, requiring users to, let's say, enter a password or validate their identity before interacting with MetaMask. But providing additional security on top of that, at least from what I've seen, is difficult.
Okay. Any other question? Let's maybe wait 1 or 2 minutes.
Okay. WASM specific security considerations. Yeah, I mean, just like any programming language, WASM can be abused. And so particularly if, depending on how you're producing the WASM code, if you're writing WASM directly, then obviously WASM is pretty low level and you can make mistakes. And so in that case, you know, I am not the most familiar with WASM myself, but I would say logical errors are probably going to be your largest concern there, because with low-level code, logic errors are really easy to write.
Just that being said, I haven't seen many usages for WASM. We had one client who used it to generate some key, and they needed to generate multiple of them, and they just couldn't make it work performance-wise with just simple JavaScript. So they wrote it in Rust. So I guess there are multiple tools and solutions. In my mind, you shouldn't. Okay, I'm saying that, but again, it's a business decision. But from a security perspective, you shouldn't rely your core business logic within WASM. It should be just like this side specific use case functions where you have to export to make other code more performant, or maybe other use cases, but your main business logic should happen on the Snap. Try to make it as simple as possible and nothing too fancy.
Yeah, thank you for the great advice. I fully agree. I think in general, you should try to simplify the code as much as possible, especially if you want people to be able to review your code. So if everything is written in WASM, then it's going to get very, very hard for people to make sure that you got the logic right. And of course, it can lead to a bunch of different issues. And yeah, of course, you add complexity, you add attack surface. So either like direct like WASM attacks, or even like if you use some kind of compilers, of course, to generate the WASM, then there is also the risk of like compiler bugs. So yeah, I think this kind of usage should be extremely limited, especially when they're run inside a trusted environment.
Yeah, when considering the programming language, also consider the library utilities that you get. So if you want to, compile something down to WASM, great. Just, in that case, try to use a language like Rust or some other languages that have utilities that are easy to use in order to do things like sanitize user input. So otherwise, you are going to have to rewrite all of that logic yourself. So just basically do a good job of choosing the programming language. If you develop WASM directly, then most likely one of the things that a security auditor is going to have to spend a long time on is ensuring you're sanitizing user input as well.
Yeah, absolutely. Thank you, John. And also thank you for mentioning tools and libraries, because I think this is something maybe we haven't talked a lot about. But yeah, when you're developing Snap, also you should, of course, make sure that you're using, you trust the dependencies that you're using. At least they do not have like critical or like known vulnerabilities. So yeah, that's also important. So well, thank you very much, guys. I think we already said a lot. Thank you for your great input, everyone. Thank you for the great questions. So we'll somewhere around this panel video, basically, we'll post a bunch of resources that our panelists compiled, basically. So please check out the resources if you want to learn more about Snaps and Snap security. And yeah, I mean, please guys, like reach out to these extremely talented people if you need like audits, and yeah, like take care, and thank you for joining.
Thank you, everyone. Feel free to send us questions if you have. We'll be happy to help if you think about stuff after this meeting. We are always available.